Christianity and the History of Science. This is number 7 in a series of 10 or maybe 11. And there will be a guest speaker, my daughter Sharon, for a large part of tonight's presentation. But first I want to set the stage. Our topic this session and next, and part of the one after it, is biology, and in particular meet the theory of evolution. Now, most Christian treatments of evolution are on way too low a scientific level. But this being a particularly brainy church, I am glad to have Sharon give us a professional scientist's point of view. But first, I want to set the stage. The amazing mystery of life. The big problem is, even if you have lots of physics and chemistry, you understand physics and chemistry very well, living things are still amazing and mysterious. They apparently know how to do complex things. A bird knows how to build a nest. A cut in your skin knows how to make new skin to heal it. So even small parts of a living thing know how to do things. And we can't see how they do it. It seems magical and mysterious, and it's quite natural to view this as the direct action of God. Well, I still view it as something God made, but now we know something more about how he does it. In the 1700s and 1800s, there was an explosion of knowledge about biology, and it didn't dispel the mystery, it made it bigger and more mysterious. Microscopes were invented. People learned about microscopic life and cells. A huge number of living things came to people's attention that they had not been aware of. Extinct species became known, and fossils. What in the world are those funny things in fossils? Was one of the big questions of the early 1800s. There was starting to be evidence that the Earth might be very old. So the problem for Christians in the 1800s was, how do we read Genesis now that we know about huge numbers of life forms and the possibility that the Earth is old? There were also atheists in the 1800s. The French Revolution had sort of given popular atheism a jump start. And the problems for atheists are, how do we explain these mysterious things so that we don't have to say it's God acting directly? How do we reduce biology to chemistry and physics so we can still believe the universe is a mechanical thing governed by fixed laws of nature? This is called reductionism, wanting to explain chemistry in terms of physics, biology in terms of chemistry, and so forth. And the nagging problem for the atheist is, if we do that, how do we feel hopeful? Is there anything to be hopeful about? Or do we just conclude that we are dying in a dead universe? Is there some principle of self-improvement built into the universe? People desperately wanted to find a godless way to believe in a hope for the future and a self-improving universe. So, with that in mind, let's meet the theory of evolution. The big event in the history of biology, perhaps the big event in the history of biology, period, certainly the big event in the 1800s, was Darwin's theory of evolution, published in 1859. Many people overestimate how much Darwin delivered. A lot of people wanted to imagine he had delivered a lot more than he had. So today's goal is to make sure that you know what the theory of evolution is, so that you don't waste time arguing about versions of it that are not current science. Or if you do, you know you're talking about an obsolete version. Evolution is built around one key idea: selective breeding. Think about how you'd breed racehorses. Suppose there were no racehorses and you wanted some. You would find some horses that were reasonably fast and breed them with each other, excluding horses that are not fast, and their offspring will be faster than average. Keep doing that generation after generation, selecting the fast ones and excluding the ones that are not so fast, and you'll get a steady supply of fast racehorses. Darwin's insight is that nature is doing this constantly. Nature has always been doing selective breeding. Whenever living things are facing a struggle for survival, the ones that are best able to survive will have more offspring. Over the generations, the whole population, the whole species will shift to be bred to survive better in that environment. Darwin's key claims are, over a huge number of generations, natural selection can actually split off a new species, not merely a new variety of an existing species. And over a huge amount of time, this explains the whole diversity of living things. So here is what Darwin delivered. Darwin delivered for the first time an idea of a way that life could have developed and diversified without any mysterious forces or mechanisms. No mysterious magic needed. Also, an explanation of the strange things that we see in fossils. They are earlier forms of life. Many are ancestors of present-day living things. What Darwin did not deliver, and this is worth noting, he did not deliver any actual knowledge of how fast evolution can work. That is, how much time does it take to build biodiversity as we know it, and has there been enough time? He didn't deliver any knowledge of how life originated. He didn't deliver any knowledge of how heredity works or how living things know how to grow or heal or reproduce. DNA and modern molecular biochemistry came along and filled in that. He did not deliver the hopefulness or self-improving principle that atheistic philosophers wanted. Evolution only says what survives, survives. It doesn't say that it gets better in any external sense. Only better at reproducing in a particular environment, not better in terms of being a nobler beast or more fit for the future or anything like that. Evolution can only choose what's fit for the present. It doesn't know the future. With that in mind, I want to introduce my daughter Sharon, who's going to give a talk now from a scientific point of view called What Evolution Ain't, and you can tell that her style is rather different from mine. I know we are all going to enjoy this, so let me get the microphone pinned on you and...
All right.
Sharon, take it away.
A lot of the basic concepts here are ones that my dad has already covered here, but hey, we have one of these weird critters that happened to the fossil record to help guide us through. First up, what this talk ain't. I'm a biology major, not a theology major. It's not going to be all about the theology, with some very notable exceptions, but mostly this is just the facts, ma'am. Silliness will occur. It's not going to be entirely serious. This is to help you remember things, because if I can get you laughing at it, I can get you interested enough to understand why you're laughing at it. This is also not a comprehensive guide. If there's any concept in here that you go, I don't remember that, or I want to learn more about that, or that's interesting, fantastic. There is a great, very common textbook, Campbell Biology, that is used not only for most Bio 101 classes, but for most AP Bio classes. And you can pick up a copy of this for under $10 online. Just make sure it's made in this century, and you'll be good. Now, we're also not going to be covering all of life. As you can see, there's a lot of it, and if some of you are going, that's not what I'm used to seeing, correct. The tree of life was completely redone in the 90s using RNA and DNA analysis. That's why there's no plants and animals in their own separate kingdoms anymore. We're just all eukaryotes. And since there's a lot of it, I'm going to be sticking to the things I actually studied with a slight mention of things I haven't studied, just the plants, because most of the rest of it is, as described, God gives his strangest battles to his weirdest little guys. So now we get into what evolution is. We've kind of already been through that, but let's take it a little more granularly. It's a change in heritable characteristics over generations in a population. Those changes are driven by the natural environment, and they accumulate over time, and this is what can cause a split into new species. In other words, some critters do better at having babies than other critters, so you get new critters. And as part one of this is something that you can't just not care about, following the truth and the way is kind of important. And it means that when truth comes along, we probably shouldn't kick it out of doors. If you're wondering why this is relevant to Christians, ask your local well-heeled theologians all around you, let them put the kettle on. It's going to be a long and thorough explanation of some of the basics. And a lot of this talk is me going, this is easy hurdles that people beef it just at the first challenge. And the gospel is important enough to not beef it at the first challenge. So we should probably dispel myths, not attach our names to something that isn't true, not make an easy error. And on that note, we will be starting with one of my pet peeves. It ain't abiogenesis. Now, to fully and thoroughly steal my innocent dad's shtick, this is one of those words that you know, but you don't know that you know it already. We know bio is in biology. We've got the meaning of Genesis on lock, that's where things start. And A at the front, well, it just means absence or without. You know, an amoral person is without morals. So abiogenesis, life coming from nothing. The thing is, this is a weird area of science that's actually much smaller and much, much less well understood than evolutionary biology. And it isn't evolutionary biology. It doesn't care at all about evolutionary biology. Nor does evolutionary biology care about it. Evolution requires life to happen. Kind of like how you wouldn't get mad at Betty Crocker for making a cake mix that doesn't have instructions on how to build an oven on the back. Betty Crocker assumes you have an oven. And evolution assumes you already have life happening. It also ain't as interesting in every single case. To see it happen really noticeably, there needs to be an exchange of heritable characteristics or genes. In animals, that's going to mean sexual reproduction. And yes, that's a word I've just said in church. I will be having the oogies about it later.
God invented it.
Yep.
Argue with him.
If everyone has the same genome, it's kind of like a class getting graded pass-fail. Either everybody wins or everybody loses. Good example of this, if you've ever tasted banana candy and wondered why it doesn't taste like a banana that you have in your pantry, is because there was an earlier variety of banana, and since they're all seedless, they're all genetically the same plant, just grown from clippings. That meant when a fungus came along, it was good at killing off all of them. So they had to switch it to another variety, but banana candy still goes with the earlier bananas for some reason. Now, it isn't possible to also know this without knowing about speciation. What is a species anyway? So like any other subject, it gets more complicated as we go on. The joke graphic says higher learning is where we argue about definitions of supposedly simple things. For example, in elementary school, we all know what a square is. Yeah, it looks like that. And then you grow up a little bit, you're like, yeah, it has 4 equal sides and 90-degree angles. Yeah. Then you get to college and say, is this a square? If so, why is it or why isn't it? Defend your answer. So it means that college and every other subject you'll find in college follows the same path. It gets interesting at the edge cases. And the more you get into it, the more you have to prove that you know what you know. So let's try to define species accurately. It means having a reproductive barrier in place. What does that mean? Well, they either can't have babies, or more importantly, their babies can't have babies. I feel like we all know that donkeys and horses are different species. Mules exist, but then you can't pure breed your mules, so they're still different species. Now, we could go over how this happens in a sensible way, or we can watch ABC's new hit show, The Bird Chillerette. So let's join Sally Sparrow when she figures out who will get the final rose. It's not going to be Dudley Dodo. He has been dead for a few hundred years. Rest in pieces, too tasty to live. It's not going to be Harry Hawk. He wants to have Sally Sparrow over for dinner. She knows what that means. She chooses life. It's not Kenny Kookaburra. She doesn't know what Kenny Kookaburra is doing. She's calling the police. They're just speaking two different languages, not able to understand each other. It's also not Oswald Ostrich, because his family has an expectation of the sizes of eggs she needs to lay, and Sally, again, chooses life. And it's not going to be Peter Penguin, because she just can't do the long distance thing. Sorry, the Skype call's breaking up. Now, finally, she meets Sam Sparrow, and they can communicate. They're in the same place. Both of them are alive, etc. Here we go, same species. Now, when this happens, when evolution happens, we know that it's not happening for no reason at all. There is a thing where changes can occur for no reason at all, but instead we call that population drift or genetic drift. But let's get into what happens when it happens. We already know that we can do it. Humans can do it. It's called artificial selection instead of natural selection. Great example for this is we found the wild cabbage and went, oh, that's got like 8 more vegetables in there, easy. We just found the brassicas and decided to select for different things, and now we have many different vegetables, some of which all taste disgusting. So if humans can do it on purpose, we know it can happen. We know that it also requires some sort of reason for it to be happening. That's the evolutionary pressure. That means it's an issue that some critters can do better than others at overcoming. A classic example, the one that inspired Darwin, are the finches of the Galapagos. When you have islands, you have the populations cut off from one another. You also have limited food resources. The island can only be so big. There's only so much stuff growing on it. So there's a pressure there of, okay, there's not as much food to go around. Who's the best at eating what we do have? And that means the finches develop slightly different beaks. You need a really strong beak, for example, to crunch to nuts and seeds. You need a long beak to get into flowers for nectar. And food is, of course, pretty useful for having babies. Finches who get the most food, get to reproduce successfully, get to flourish and succeed in a way. This means that this keeps going on and on and on, and different finch species develop. The fruit eaters can't understand the seed eaters. They don't understand why those nectar eaters got such long schnozzes. They're not into it. And again, it can't happen by coincidence. This is called population drift or genetic drift. There's plenty that evolution simply does not care about. It neither helps nor hinders, it's just there. Keep this in mind for later when we talk about evidence for it. It also isn't a thing that means the best critter wins. This is another pet peeve. For an example, let's consider the octopus. They're pretty cool critters. Very, very intelligent, to the point where aquariums sometimes have trouble keeping them, so they'll just outsmart the aquarium keepers. They're able to fit into all sorts of places. They have 8 very cool limbs. And, you know, they even have eyes that are technically better than our own. They can see just as well as we do, but our brains have to flip the image right side up. Theirs don't. So you can look at all of this and go, wow, that's a good critter. Maybe even the best critter. None of these things help if you drop the octopus into the Mojave Desert. So, Survival of the fittest is one of those quotes where people stop at the first half and forget that the last half changes the meaning. It's very similar to the customer is always right, and that doesn't mean just do whatever the customer wants. The full quote is, the customer is always right in matters of taste. So shut up and sell them the hideous green sofa they want. It's fine. Evolution does not mean that you're working towards perfection. It's just good enough. It's duct taped together kludges that are specific for that environment. And survival also doesn't really mean survives to live a long and happy life. Evolution just cares about, are you making babies? Great, how many of them can you make? So this means that we get some counterintuitive things, like male peacocks, beautiful long tails that drag them down, beautiful long tails that make them want, a little bit of barbecue sauce for their passing jaguars. But it works somehow because the peahens say, oh, what a cutie, I gotta get in there. So they die early, yes, but as far as evolution is concerned, they've won. It also is not a thing that justifies bigotry. This is another major pet peeve. One of the things that humans do is we use tools. This means that, well, a major evolutionary pressure completely negated. And so once we figure out that a lot of this doesn't quite apply to us anymore because, of course, I didn't have genes for making glasses to have glasses, I just went to lens crafters. It means that we're not quite facing the same pressures other critters do. And, well, it's slow. If anyone here has had their wisdom teeth out, probably most of you, that's actually evolution not quite catching up to the idea that we're cooking our food yet. As in, well, your teeth are gonna fall out because you're eating all of this rough stuff, right? So you're gonna need extra ones. Unfortunately, we don't need the extra ones because we have ovens and microwaves. So compared to that, differences between races are so much newer, so much smaller, and so much more insignificant that if anyone is trying to pitch you on racial superiority for evolution's sake, they're trying to sell you something. And honestly, Darwin was just as frustrated with them at the time as I am now. It all depends on fittest meaning best, which, if we remember our octopus, doesn't really work like that. And of course, eugenics is a moral evil. As a disabled person, I have some thoughts about this, expressed by Bugs Bunny. For more information, see your local World War II history enthusiast, because we did in fact have a war about this one. And if you don't see how Christianity doesn't jive with eugenics, again, ask our local knowledgeable theologians, and they're going to put the kettle on. It's going to be a long and thorough explanation of how you got so wrong. And, well, however fit somebody may be to consider themselves to survive, nobody ended up evolving a way to get out of sin, so Jesus Christ didn't have to do anything about it. On to less theological matters. It ain't something that stopped with Darwin. Science is an iterative process. It's not good at keeping around chaff that doesn't work. You can't really disprove just Darwin and say the whole thing is bunk. For one thing, Darwin was disproving Darwin. That's why his books had multiple editions. That's why he had multiple books. There's plenty of things that he admitted he didn't know, and plenty of things that he actively studied and revised. Now, if any of the core idea there hasn't changed much because it's been tested and not found wanting. It has been iterated on and continually pressed against. So if there's specific details that you're like, I don't know about that, great news, science is ahead of you. Science also doesn't know about that, and science will be happy to tell you about it. If details of how this is happening are new to you, Well, quite frankly, the sausage making never stops. Science is always a treadmill. You're always running to catch up. And I think that's kind of great about it. We know that we don't know things. We also don't know that we don't know even more things. And, well, we're working to find out what we can find out. So if some of this is completely new to you, yeah, it probably is. Now, this is, again, something where I'm going to leave the really heavy lifting of theology to others, but it ain't a thing that inherently conflicts with Christianity. It's studying the natural world, which is God's creation. The minutiae of how it all fits together is another talk entirely, but I find it useful to often look at sources that are a little bit more doctrinally conservative, or at least have spent a lot of time thinking about how doctrine fits together with the world. And, well, the Catholic Church is a notable repository of people who are smarter than me and has been that for several hundred years. And I think it's useful to know that they have thought about this thoroughly and they have come to completely accept evolution. And there are plenty of Jesuit scholars out there who will step you through every little detail because they've been the ones thinking about it. Of course, there are other repositories of Christian learning and Christian thought, but sometimes it's nice to just know that, yeah, there's a big name out there who will debate this and has debated this and has found this to their satisfaction. So we can disagree with them doctrinally, but we can also go to them and say, okay, we know you're so fuddy-duddy that we actually split off from your fuddy-duddiness, but what you got? And then we can figure out if we agree with them or not. It's something that has been thought about. I will say that a thing evolution conflicts with is young earthism. However, it's not alone at all. If anything, you're going to end up with evolutionary biology's older brothers, such as geology, astronomy, etc., being even more incompatible with these things. Now, it also ain't a thing with no evidence. I'm sure that we all know the iconic jazz hands of Archaeopteryx here. But I think that there are so many sources of proof that I'm going to talk about one of the newer ones that I find very exciting. It's junk DNA. Now, I think we all know that when you're printing something, you have margins because you don't want your text to get lost. If you're making a book, cutting up manuscripts, you want that wiggle room. Otherwise, you're going to be missing half a paragraph because somebody sneezed. And DNA kind of does the same thing. There's segments of DNA that don't encode anything, don't do anything, they're padding. Usually at the beginning and end of the good stuff, because if something's going to go wrong, you'd rather have it go wrong when it's transcribing the nonsense bit that doesn't matter than the stuff that really matters. And since it doesn't do anything, evolution doesn't care about it. It just gets copied. It's a true neutral thing. And because of that, we have a really useful way to chart differences. We can make those phylogenetic trees saying, okay, here's a stretch of code. Here's how it's changed a little bit. Here's a critter, it's changed a lot more, and a lot more, and a lot more. Because this DNA can still change. You can still have errors in transcription. You can still have a UV particle bouncing around there and being like, I flipped it over for you. Thanks, UV particle. And again, because it doesn't do anything, evolution doesn't care about it. So we get this really nice record, kind of like almost a guest book of what changes are happening where. And it's one of those things kind of like radiocarbon dating, where the random chance that a mutation will occur is still random, but you happen to catch it in a long enough time, and it can almost equal out to something that isn't random, sort of like radiocarbon dating. The individual carbon molecule that's going to jettison an electron or something may be completely random, but we still know how to calculate things like a half-life and go, okay, we know approximately how much carbon has undergone this. We know a very rough age. But it's much, much better at doing the differences between A to B. And it ain't saying we're monkeys. We have a common ancestor in our family tree. We also have a common ancestor with many other things, going back far enough. My favorite here is Jeremiah, which is a little critter from the Jurassic period who is a tiny shrew and spent most of its time running around screaming, trying to not get eaten by dinosaurs. And one of the first mammals that we know about. So, great, et cetera, grandma is a tiny shrew screaming about how it doesn't want to get eaten by velociraptors. And I just think that that is also a way to stay humbled, a way to stay connected to the fact that we are part of God's creation. After all, we are but dust, to dust we will return, and we are but screaming little shrews that can get eaten by velociraptors if God wants that to happen. And it also isn't disproven because monkeys still exist. This is one of those baffling counter-arguments that I come across every so often. This is rather like saying that your cousin existing disproves that your grandmother exists. No, you're both at the family reunion because your grandma's there. It's just that, we went a different route than the monkeys and chimpanzees did. Now, this is the section where, if nothing else, I want you to remember this bit as I wander into theology. It wasn't a thing made by a man to destroy God. Darwin is actually a Christian when he developed this theory. He actually showed up at Cambridge wanting to do a divinity degree, and then realized that would require taking another test, and he decided to slack off and go hunting instead, which, understandable. So, he was still following the thought of the time, which was very much that you studied natural history to appreciate God's creation. This is how you saw the glory of God in his works. Did he have a crisis of faith? Yes. Was his crisis of faith related to his work? No. It was because of this. He was already starting to be troubled by the question of evil, the question of why bad things happen in a universe, in a world that God made. And then his eldest daughter, Anne, grew sick and held on for a year, getting worse and worse until she finally died at age 10. You can see from his memoir how he felt about that. And he was very upfront in telling people this was the thing that made him lose faith in God. This is the tragedy that dimmed God's light for him. This is not something where he lost his faith because he wanted to go kill God with evolution. This is a man who mourned his daughter deeply and was so overcome by grief that he could not find Jesus Christ anymore. Why is this important to know? Well, it feels good to be the dragon slayer. It feels good to have an easy enemy that we don't have to think about, we should be compassionate to them, because they're the dragon. You don't make friends with the dragon, you stab the dragon. The heroic knight never sits down with the dragon with a cup of coffee, asks him what's up. It feels good to have that simple narrative because we get to be the hero. And I'm not even going to say that there's not such a thing as a dragon that needs slaying. I mean, see the Bugs Bunny quote earlier. But turning someone who is drowning in grief into a dragon to slay is not how we show Christ-like compassion. It's an excuse to ignore that pain. It's an excuse to demonize them for having that pain. Tilting at windmills means that we don't see the people around us who need help to see God's light. It means that this is a dangerous impediment both to sharing the gospel and to our own salvation, because what happens when we have doubts? What happens when we are bothered by evil in the world? Do we become the dragon? Are we just all bad? No, we need to have compassion as Christ taught us. And Darwin is one of those figures that, if nothing else from this talk, I hope you'll remember him as a guy to have compassion for. He wasn't out to destroy Christianity. He wasn't out to kill God by rebuking him. He was mourning deeply for his beloved daughter. And that is not something that I think we need to make him into the enemy for. Because who knows who among us we walk past 5 times a day, 10 times a day, who among us in this room will find themselves or have found themselves in a similar position? If we let people become demons and dragons and write them off for this, we're committing a cruelty that is hard to undo. And finally, here's part two to it's not a thing that you can just not care about. The thing about biology is that it's happening all the time. We are biology. You can never escape it. You are at best biology wanting to ignore biology. We are not immune to being part of God's creation, and I find this thrilling, actually. And all of this helps you to understand the world around you. For example, if you know what a species is, you know to not plant your yellow squash next to your zucchini, because you can look on the packet and go, oh, these are the same species. My salad's going to get really weird if I do that, because they're going to interbreed. You're going to have zucchini squash hybrids. And you probably don't want to use that for your zucchini bread or your squash casserole. And another great example, if you've ever wondered, well, why do doctors always nag me about finishing my antibiotics? Like, oh, I feel fine now. Well, it's because we've become the evolutionary pressure to the bacteria inside us. And if we don't kind of finish the job, then we've just kind of been that halfway. And that means that the bacteria that survive and thrive are going to be the ones that resist that evolutionary pressure, resist the antibiotic. And so it's bad if we give the ones who are most resistant a chance to spread and share that information, as it were, among other bacteria. It's just extremely relevant to all of us right now. It helps us appreciate what we're doing here, why we're doing it, and I just think it's neat, especially Jeremiah. So, there are some questions available if time allows, and I will pass this back to my dad if he's got any more slides.
Right, I need to announce a couple of things, and then we will stop recording and then have our question time. Thank you, Sharon. That was very good. So we're going to still be doing biology next time, and in particular, the cultural and biblical response to evolution is coming up next time. So I know you're all eager to hash out all kinds of things that are going to take more than one session. Next time is in 2 weeks, right? We are skipping a Wednesday because of the fall festival. Then we resume for apparently for several more sessions, grand total of 10 I originally planned, and we'll do something for an 11th one. So thank you for coming.